right, in this one we have to do distributive first and then combine like radicals. Watch what happens here. I've got to multiply like that. Minus 4 times 3, negative 12 root 12. You know how I got the 12 there? 6 times 2. Minus 4 times minus 5 plus 20 root 18 plus 5 root 48. Now I have to simplify the rest of this. 12, let's see, 4 times 3. There's a perfect square. So, negative 24 root 3. 18. How about 9 and 2? Perfect square. Comes out as a 3, so that's going to give me 60 root 2. How about, 48. 16 and 3. That would give me 20 root 3. Now, do I have any like terms? Oh yeah, right there. So, how about negative 4 root 3 plus 60 root 2. That is the answer. Okay, in this one, I'm going to write this as two separate fractions first. 3 root 40 over root 8 plus 2 root 24 over root 8 minus root 5. Then I can reduce this part here. 8 into 40 is 5. So I could call this 3 root 5 plus 2 root, hope you said 3. Now, let's combine like terms. You see anything alike here? 3 root 5, take away 1 root 5. 2 root 5 plus 2 root 3. Can I add those two together? Shall we do that? I hope you said no, not like terms. All right, again, it looks like we don't have any like terms, but there's certainly some simplifying to do in some of these, so let's do some simplifying. I like to break things up into multiples that show perfect squares. So 12, you could use 2 times 6, you could use 4 times 3. I like 4 times 3. Do you know why? 4 is a perfect square. X to the 5th, I could call it x to the 4th times x minus x square root 3 times x squared times x plus 5x squared root 3x. Nothing can simplify there. Now, I have some perfect squares I can take out. Here I can take out a 2. Here I can take out x squared. So 2x squared, and what's left inside? 3x. All right, what about here? Oh, x squared comes out as an x, times it by that, minus x squared root 3x plus 5x squared root 3x. Now I have all like terms. I have 2, take away 1, plus 5. I hope you realize that's 6x squared root 3x. Final answer. This problem looks a little bit tricky. I have 2 parts to combine, but one part has a fraction. Let's rationalize the denominator of that fraction first. Do you know what I would do here? Multiply by root 2 over root 2. You know root 2 over root 2 is 1. So multiplying the fraction by 1. I'm not changing its value. I'm making it look different though. Now I get root 6y minus root 6y over root 4. Hey, root 4. What could I do with that? How about this? Let's go root 6y minus root 6y over 2. You with me so far? Can I make this a fraction? Sure. Put a 1 under it. I wish I had common denominators. You know how to do that? Sure you do. All right. We'll multiply this by 2 over 2. 2 over 2 is 1. Not changing the value, just making it look different. That gives me 2 root 6y over 2 minus root 6y over 2. No number in front of this, I'm going to put a 1 there. Helps me thinking this through a little bit. 2 root 6y over 2, take away 1 root 6y over 2, is 1 root 6y over 2, which is really root 6y over 2. So, I wonder if I circled that answer too quick. Can I divide that 2 into that 6? I hope you said no. If that 2 was in a radical, I could. That is the answer. So be careful when you get to the end.